Uh, Welcome again. In this example here, we'll try also to use what we learned about the superposition principle, which hopefully will help us to solve similar type of questions. Now we have a system of point charges. They are distributed on a square. Each one is in a corner, as you can see here. The Q1 is 1.5 microcoulombs, Q2 is 2.5 microcoulomb, Q3 is minus 3.5 microcoulomb, and Q4 is 4.5. So they have different magnitude of charge, and there's like this is a square. Now the question here, what is the magnitude of the electric force on Q4 resulting from the electric force from the remaining three charges? Now the question here, what is the net force acting on this Q4? This is like the question. How do we solve this question? As we said, like in the superposition principle, we have to look at the target charge, which is in this case is Q4. Then I need to look at the interaction of this Q4 with each point charge separately. Then after I identify the force from each charge separately, then I will end up with what? Many forces with a different direction. Then I use the vector summation to find the net force. So let's start with Q4 and Q1. Q1 is positive, Q4 is positive. The force will be parallel to the line that is connecting with these two. In which direction it will go? Since this is like a repulsive force, so I will use like F1 as this one. I will drop the 4 in this case, just like F1. That's the force that's coming from the first charge. So this is like the target. This is the charge that we are trying to find the net force at. And how do we know this one? Because that's the question. What is the net force acting on a Q4? Now, the same thing I will try to apply for Q3. What is the charge? Q3 here is negative. What's the charge of Q4 is positive. So in this case, how do we, in which direction the force? We know like the force will be again parallel to the line connecting between these two. Since it's an attractive force because they have opposite charge, so this will give me here what? F3. So F3 is going in which direction? Down. Now, the third force actually will come from the Q2. Now Q2 again, how can we find the force? It will be parallel to the line that is connecting with these two charges. And since this is positive and this one is positive, what kind of force we have? It's a repulsive force. So that's to give me here what? F2. As simple as that. Now, how many forces do we have here? We have 3 forces. Now, these 3 forces, as you can see here, each one is in a different direction. Sorry, okay. Now, in this case, we have, this is F3, F1. Now, we know like F1, it's in which direction? It's in the positive X, I hat. That's perfect. F3, in which direction? It's negative J hat. Y, it's pointing down. F2 has 2 components, one X and one Y. So let's try then, after we do this one. So in this case, F1, it will be what? Positive I hat. Now, what's the magnitude in this case? That's the point here. It will be K. Q4, Q1 divided by what? A square. What's A? In this case, that's the distance A. Now, again here, I don't care about the charge. In this case, I only care about what? Magnitude. Why? Because I already have the sign. The direction is already done. So all what I need to do here, I just need to find the magnitude. So I have the magnitude of Q4 and I have the magnitude of Q1. So I don't need to put the negative charge in this case. Why? Again, because I already find the direction. So in this type of superposition principle, if we identify the direction, positive I hat, negative I hat, positive J hat, negative J hat, after we identify the direction, then I only take about what? the magnitude of the force. So we just substitute the magnitude, and that's what we are doing here. So in this case, we have Q4, we have Q1, we have A, then we can find F1, and that's the first part. The second part now, I need to find what? F3. F3 here as a vector, sorry, it will be in which direction? Minus, as we said, like minus j hat. Why it's minus j hat? Because look at this one, F3 is going down. Now what's the magnitude of this one? It will be K, Q3, Q4 divided by again A square. Why A? Because the distance between these two charges is given as what? The length of that square, which is A in this case, and that's the third force. Now F2 is the one that is a little bit needs some work. Now why is that? Because this one has a direction. Now according to what we learn here, this is a 45 degree because this is a square. So this line actually will make like 45 degree. So that's why the angle here will be 45 degrees. That's why F2 will have what? F2x I hat plus F2 y j hat. F2x will equal what? F2 times cosine 45 I hat, and F2y will be what here? F2 sine 45 degree, again j hat. Now what's F2? F2 we know it. It should be K, Q2, Q4, again the max, we don't care about the sign here, divide by what? This distance R. This distance R, by the way, according to the triangle here, this is A, this is A, so R square equal what? 2A square, so R equal what? Square root of 2 times A, so it will be here what? 2 square root of 2A and all square. Now since we have this, I substitute here, I substitute here, and in this case I'll be able to find what? F2. Now F2 has X component and has Y component. The X component of F2 will be added to what? To the F1. And the Y component of F2 will be added to what? To F3. But keep in mind that F3 here is what? Is negative. So in this case, if you look at it here, the X component, as you can see here, with the Q1 and this one, and for the Y component, we will have here the negative. But here in this question here, we already have the negative sign, keep in mind, and that will give me the same answer. So in this case, I can say that F4 net will equal, as we say here, as we say, like it will be K, Q1, Q4 divided by A square plus K, Q4, Q2, again absolute value, divide by 2A square, and that will give me here what? Cosine 45 degree, and this is like, this is I hat plus K, Q, 3, Q4 minus A square, and we have what here? A minus sign. Why minus sign? Because it's already pointing down, plus K, Q, 2, Q4, again absolute value. We don't care about the magnitude because we already signed the direction, and that will give me here what? 2A square, and that will give me sine 45 degree, and that will be here what? J hat. Now since we have this, we can substitute the values that we have here, then you can find what? F net 4 as a magnitude. We know, like in this case, it will be what? F net x square plus F net y square under square root. This is how we solve this question. Hopefully you understand what we are doing, and if you have any questions, you can ask me during the online session. Thank you very much.